Hi YouTube, in the last episode of Universe Sandbox I promised a supernova. I promised to end with a supernova, but I didn't. So I'm gonna start this episode by with a supernova, by forming a supernova. So in the Universe Sandbox this is pretty easily done. You just have to throw one star into another and that should be enough. Let's just see in slow motion. Here is not very slow motion, but as you can see, both suns exploded into a supernova that is now expanding at the speed of light outwards into the unknown universe, which in this case is pretty empty because I created it and it only had 2 stars which have now exploded into a gazillion different fragments. For example, we have this, it has 80 Jupiter masses, so it's now forming a planet. Now this is interesting. Are they all like this? So this has almost 3 Jupiter masses, and they are all pretty hot, but eventually you could maybe see planets forming. I lost my 80 Jupiter masses planets, but we have one with 10, and it's already formed into a gas giant. As you can see, a pretty white gas giant. Let's just cool it down to 0. It already burned out again. Yeah, because we are in the middle of a supernova, so it figures it's difficult to cool down a planet. It's composed 100% of hydrogen, so we have a giant, I would say a protostar, because it is 100% hydrogen and it has the mass of, it's lost some mass, okay, but it had the mass of 10 Jupiters or something. So yeah. So in this episode I'm going to look into black holes. You can add black holes. Obviously, where is it? Black holes. You can add. I just had one small black hole with the mass of the sun. So here we are. What's going on? Where is it? Here we go. I lost my black hole. That's not very good. So here we are, distorting the light beneath it or around it. Let's add some big star. I don't know what's the biggest star that is in here. Well, let's put it in. Whoa. Okay. So this is pretty good. Well, this is pretty. Let's add this one, orbiting the black hole. I think it's falling. Yeah. Okay. Okay. So I would think this is a gas. A gas? No, but well, I was thinking geogas. This is a fail, I would say. I wanted the star to orbit the black hole, so let's have this one and see if this one orbits like we intended to do. Okay, so finally that star was absorbed by the black hole, and now the black hole gains some movement due to that due to the attraction pull of at the Carinae A, and now we have a black hole orbiting Eta Carinae and Eta Carinae A orbiting a black hole with one mass of the sun, and I think they are getting nearer each other. I don't know if it's just me or. So the radius of this star is 2 astronomical units. This is pretty astonishing. That's the radius, and this is the radius, not the diameter. It's 2 times the distance from the sun to Earth. So the star, from one side to the other, it's 4 times the distance between planet Earth and sun. So this is pretty massive star. Let's add another black hole, one slightly bigger, 100 sun masses, orbiting far away. okay, in here, and let's see what's going to happen. Let's give it some time. Oh, so the binary system ejected the 100 masses black hole into interstellar space. Okay, that was unexpected. Let's add 10 million. A black hole with 10 million masses of the sun. So what I'm expecting is both this, both the black hole and eta Carinae will be absorbed by this black hole. And I'm gonna put it in still mode behind them. Let's see if okay. It was too fast. Oh, and there comes another black hole passing through it. Okay, so what we witnessed was that this black hole was simply too massive, and it I mean, I was simulating way too fast, and it was look at the size of Pluto next to this thing. And what happened is that it instantly dropped. I mean, this thing is, look at it. Look at how fast our sun is orbiting. So this is our sun relative to the size of that black hole. Look at how fast it has to orbit the black hole to just don't fall. I'm simulating at 1 minute 25 seconds per second. So 1 second equals 25 seconds simulated. So half a minute. Look at how fast our sun is orbiting this planet, this black hole. So let's just simulate random stars, put them all into orbits. There's nothing better than random stars simulated. So one big ass star there. So there's a lot of light already. Let's just add them. When my computer crashes, well, who cares? So yeah, let's see if we can get any supernovas and shit. Let's see just what happens. Okay, so we have now a shit ton of stars orbiting our 10 million masses of sun black hole. This one is pretty cool. This blue one, this Optimus, right next to a Kepler 2b and Lard. Oh, there we go. We have one supernova event. So we have two stars that have already collided with each other. And look at, it's like it's spread out the cloud. Let's try to simulate a little bit faster. See if my computer doesn't crash and if I can show you what's going to happen. Oh, I don't even know how this one's got here. I mean, what the heck? So I can see the momentum of the supernova continued that way. Oh, we have another supernova in here. Oh, this is amazing, man. I wasn't expecting this. I mean, they are orbiting so fast that the supernova core is just, I mean, they are so fast that the supernova is just ejecting out of orbit and forming this beautiful pattern. Well, I'm just gonna simulate a little bit faster. Let's hope the computer doesn't crash and hope for more supernovas and see, just see what's going to happen. I mean, we should be getting a lot more of supernovas. There are a lot of stars orbiting in here. And there we go, we have another. I'm just disable the trails so the simulation gets better. And we don't need the trails, they are just a blaze of light. So we have another supernova event. So this is absolutely magnificent. Look at this. So in the last video I promised you supernovas, and now we have supernova galore. I mean, look at this. They are traveling so fast that the supernovas just get spread out due to the, I don't know, maybe to the centripetal force. I could say nonsense. I could be saying nonsense. I have no idea actually. But I wouldn't be surprised if that were the case. So we have almost a lot of the stars have collided already. They are colliding as we speak. Look at it. It's like a cloud of dust just emanating into the infinity of outer space. It's just what's going on in here, where we have a trail of fire. So we have our black hole just distorting, what am I saying? Distorting all of the light that comes around it. It's pretty badass, I would say. Yeah, this, okay, you have to be this zoomed in to fully appreciate the work of art that's going on in here. I mean, between the supernovas and the show of light, this is just amazing. So the supernovas are spreading out at the speed of light, if I'm not mistaken, so that's why they are traveling so fast. But even still, our suns are traveling at stupid speeds. We are talking kilometers per second. Let me see if I can change meters per second. I'm gonna put it in meters per second. Kilometers per hour. Where's here we are? Yeah, they are. So as you can see, yeah, that's why probably why the simulation is breaking. I mean, they are traveling faster than light, right? 1, 2, 3. Yeah, I mean, so they are orbiting the black hole faster than the speed of light. That's why maybe we only see the outer part of the supernovas, because the innermost part got absorbed into the black hole. So, I would say with this spectacle, it's time to end this video. So there's another supernova right there. So thank you for watching. This was 3 Onion with Universe Sandbox Squared. Goodbye.